Hey guys, it's Rob Menti from MicroStrategies. Like Kelly said, we're here to talk about OpenShift virtualization. A lot of folks are familiar with OpenShift, being one of the primary container platforms in use out there in the industry. But really, when we dive into the concept of moving virtual machines onto the container platform, instead of taking the step of actually containerizing their application, that's really what we're going to be talking about here today, kind of that stepping stone into modernization, where you can keep running your VMs and move those over. One of the things I wanted to start with when we talk about this conversation is at our briefing center in Parsippany, New Jersey, we have all the technologies we're going to be discussing here today. So it's a place you can come, get hands-on OpenShift, get hands-on OpenShift virtualization. We have it running here in the room. We're attached to all the major clouds. We certainly have VMware and Nutanix and other things running sidecar alongside of it because we understand that in real-world environments, it's not very sanitary, right? Sometimes you get to a demo environment and it's clean and it's pristine and it's not indicative of your environment that has mixed server, mixed storage, mixed hypervisor, cloud-based workloads, whatever it may be. So we always invite our customers to come spend time in our lab. This is also the place where our guys get, smart on all the different technologies. So whenever we try to work with something that comes out into the marketplace, OpenShift's been out quite a long time. But when OpenShift virtualization really started to rise, we spent quite a bit of time in the lab making sure we understood all the nuances. So it's a place where our experts get smart. It's a place where your folks can come get their hands on. And that's also good because if you put something into your production environment, it's probably not the place to be learning. So come learn on our stuff. If you're not super close to Parsippany, we certainly can offer VPN access in to the lab environment to be able to do that remotely as well as a screen share. Just as a preamble, before I hand it over to Grant, who will be our primary speaker today, just the reason most folks want to have this conversation is because of the changes Broadcom has brought to the VMware licensing, right? They've gotten rid of many hundreds of SKUs, and they've really gone to just these couple. So these are the only things you can really buy from Broadcom at this point when it comes to VMware. The couple on the left are very much edge cases, desktop essentials, which is any site that has less than 3 servers. And that's actually still fairly cost effective. So if you have a small environment or a satellite environment, Essentials is a great offering. Standard is just a single server, so we run into those once in a while, obviously. But most folks are here on the right-hand side. vSphere Foundation, which is really just ESX and vCenter effectively, and some of the operational bits from ARIA. But the one that Broadcom really wants you to use is VMware Cloud Foundation, right? That is the kitchen sink offering. It contains all of the VMware stuff. It contains their virtual servers, their virtual networks, their virtual storage, their operations with ARIA, their automation with ARIA, right? So depending on where you are in your current deployment, if you're just running VMs, right, and doing some light automation, Foundation's perfectly fine. If you run into a situation where you're really investing heavily in the VMware stack, then obviously VMware Cloud Foundation is the place you're going to go. And the further to the right you are, the more you're going to have to replace, right? So at the end of the day, if you need to take your automation stack or your storage stack or your network stack and replace it with other things, that's a harder road to go down, right? Not impossible, but certainly something that takes a little more time. VMware's take, or Broadcom's take, excuse me, and we are a Broadcom partner, full disclosure, right, is they want you to go into a larger commitment, 3 years, even 5 years, and all the way to the right in Cloud Foundation. And they say if you do that, they'll make that a little more advantageous to you. But a lot of folks are really pushing towards the 1 year. A lot of folks are pushing towards Foundation, trying to just keep the VMs running until they figure out what to do next. And it's not like you're going to necessarily not have VMware in your life, right, moving forward. It's certainly possible where you shrink the VMware footprint. So as we have this conversation today, don't think of it necessarily of I'm going to turn off all my VMware and move everything to OpenShift virtualization. Think of it more in terms of, are there workloads that can make this move that will shrink that VMware footprint, that'll make that VMware cost lower, because the less machines I'm running and the less CPUs I'm running, the less that VMware cost is going to be. So most folks are on this path of shrinking the footprint and then deciding that they want to keep some VMware in the environment, that they need to keep some VMware in the environment, or are they going to really move away to other things over time? So that really is the reason I think folks are having the conversation. This change has really pushed people to think differently about their workloads. And we certainly can have the conversation of modernizing those workloads, moving them to containers, moving them to cloud, but that's very hard. So keeping them as VMs, I think, is the conversation we're going to have here today. And with that, I'm going to hand that over to Grant to start the conversation about OpenShift virtualization.
Thanks, Ron. Go ahead and kick it over to the next slide. So, first of all, my name is Grant Delavecchia. I've been working with VMware and OpenShift. I've been in the data center infrastructure for 30 years is what I've done in my career. So, as Ron mentioned, Broadcom did what they did, and now people are looking for alternatives, right? So, OpenShift virtualization is new. It's not new. It's only new because people are interested in it now, right? It's been around since 2017 as an official product. It's the technology is based on KVM, which has been around and it's had parity with VMware for more than 10 years. So, again, it's new in the sense that most people never heard of it before, but that doesn't mean that it's necessarily new. So, obviously, the goal to moving towards OpenShift virtualization, I mean, each customer has their own reasons for doing that. There are lots and lots of compelling reasons, and we'll talk about some of them today. But mostly, everyone has their own reasons to do that. In the context of this conversation, we are talking about VMware as a traditional virtualization platform and OpenShift as a modern virtualization or just a modern platform. And just a little brief on that. VMware is 30 years old, right? Now I realize that it doesn't seem like that to us, but it is 30 years old. And that technology, the hypervisor technology, hasn't really changed in a long time. And that's great because it's good. It works fine. Everybody's happy with it. We know how it works. Everything's good. Kubernetes, on the other hand, is not an existing technology, an old thing, right? It's relatively new. It was invented by Google about 10 years ago to automate their whatever Google magic they got going on in their data centers and all the rest of that kind of fun stuff. And so that's the perspective that we're coming from. Go ahead to the next slide. There we go. So one of the big pluses with OpenShift virtualization is it gives you the opportunity to manage your virtual machines, the virtual machines you run today, and your containers in one place. Now, maybe you guys aren't doing containers yet. Okay, that's fine. You don't have to. You don't have to leverage that capability. However, in the event that you want to, or that you have the plans to do that, moving your virtual machines to OpenShift virtualization gives you the option to do that, right? And that is very powerful, and I'll explain to you why. One of the biggest bonuses or pluses or strengths of containerization is the microservices architecture. Now, this is a conceptual thing. So, generally speaking, when we make applications, they're one big application that does everything inside. So if you take this one giant Java app or whatever web app thing you have, and it has 50 functions inside, that's one monolithic application. A microservices architecture would be taking those 50 functions and breaking them out into individual functions, into microservices, and then applying them inside the environment, managing them inside OpenShift with Kubernetes, and all that kind of stuff. The advantages to that are it allows you to scale where you need to scale. So instead of having to spin up 10 virtual machines to manage this one giant web app, because that's what you have to do to scale it, you just scale the layers that you need to. The really important thing about that is that if you have a functioning microservices architecture, moving your virtual machines into OpenShift allows your virtual machines to participate in your microservices architecture. And really, all this is getting at is flexibility. It gives you options. It gives you options on how you want to, do I want to keep this as a virtual machine? Do I want to move it to a container? What are the advantages? Because sometimes, for databases and other things, containers are not a great fit, right? And if you just go into the container road, you have no option but to do containers. Well, this gives you the option to do both. You have the best of all the worlds, kind of, right? All right, let's go ahead and, one thing I wanted to mention, OpenShift Virtualization does support the Microsoft Server Virtualization Program, blah, blah, blah. I'm not sure what that is, but I'm guessing it's bundles with subscriptions and stuff or licenses. And as far as RHEL goes, if you any RHEL instances that you put on OpenShift, they are no cost to you. So if you have a Unix footprint in your environment and it's not RHEL, you may want to move to that and save yourself some money. All right, go ahead to the next slide.
Yeah, I think right before I go to the slide, that's a pretty important point, right? If you have a Red Hat set of environments, right? If you think about what Grant just said, if I take those Linux, Red Hat Enterprise Linux VMs and I move them to OpenShift Virtualization, not only do I avoid the VMware cost of where they used to live, I also avoid the Red Hat Linux cost. So when you think about cost avoidance, you're thinking about the balance of where the dollars are going. The investment in the OpenShift virtualization platform, you have some takes when you do that part. And the Microsoft Server Virtualization Validation, again, we're a pretty strong Microsoft partner. It really just means Microsoft is going to support that, right? When you call for Microsoft support, they don't go, what are you running on? Yeah, we don't support that thing. They will support you running a valid guest environment that you have support on top of the OpenShift virtualization stack.
I'm glad you explained that, Ron, because I had no idea what that is. I'm not a Windows guy, so I don't know. All right, so virtual machines can be put into containers. Basically, a container, what we call them pods, right? That's the general concept for a container. A container is an individual application, as in, you got a web app and it's PHP, and that's what's in the container. A pod can be more than one container. So we're just going to use the word pods because that's the accepted concept. And what a virtual machine is on OpenShift is a pod with KVM in it, and then your virtual machine sitting on top of that. So if you think about your current virtualization strategy, you have ESX, and you have an ESX server that's running a hypervisor on it, and you put a whole bunch of virtual machines on there. You have one hypervisor and a lot of virtual machines. The way that OpenShift does it is you have one hypervisor for one virtual machine, right? Each virtual machine has its own hypervisor and its KVM sitting in the bottom of the pod, right? So not that one way is better than the other. There are pluses and minuses to both. OpenShift does it different. That should be the overwhelming message you get from this presentation and this event today, is that you can achieve the same goals. It has the same functionality across between VMware and OpenShift. How they go about doing it, very different, right? And mostly that is because VMware is an analog to physical, right? Everything you have in the physical data center, you have a virtualized version of it in VMware. That is one of the reasons we have the limitations that we have with VMware, because they're dealing with physical limitations and constraints. OpenShift doesn't care about that stuff. It doesn't do that. It doesn't try to make layer 3 switches. It just doesn't care. It does what it does because that's what it wants to do. And that was how it was written to do that. It wasn't written to be constrained, or let's say Kubernetes was not written to be constrained by physical limitations. So it doesn't have a lot of them. I realize that may seem scary, but it's not as bad as I'm making it out to be. So you have a pod, you have a virtual machine. Inside the container, everything's copacetic. Kubernetes doesn't care. It treats them exactly the same way. You specify the resources that it requires, and it finds the best place to put that virtual machine or that pod based on its requirements. Plain and simple. Do you have any questions about that from anybody?
Well, I have a comment as we look for questions, Grant. I mean, I think that the concept here, this decoupling of the hardware from the layer is a pretty important one. And Grant is going to go into a demo, so this will become a little more crystallized when it shows you the interface and kind of shows you how those resources get allocated. At the end of the day, the thing to keep in mind too is when you go down this path, the application doesn't care. The end user doesn't care, right? When I attach to a server, when I RDP into Windows or whatever it is, I don't know or see that it's running in this way, right? I'm still interacting with the VM the way I've always interacted with the VM. This is really more of a comment of how the VM itself interacts with the underlying layer. And it is certainly still a virtual machine. I mean, one of the things when you think about containers, you grow them, you shrink them, you blow them away, you rebuild them, right? There's no patching. You don't patch. You build it. You build a new container with the new stuff you need, and you turn off the old one, and you do that seamlessly, right? That doesn't work this way. It's still a VM. So the VM is going to be there. It'll be more persistent. It'll still need care and feeding in the normal way that you're care and feeding for them today underneath VMware. Um, but it is, again, it's a good stepping stone into this concept of containerization, because it's going to let you to run the way you've always run and interact with your workloads the way you've always interacted with them. In the meantime, we're saying, okay, is there a way to now take that next step into modernization, containerization? And for some workload, that's not going to happen anytime soon. They're just going to run as a VM for as far as the eye can see. But you do now have options, because once you're in this pod, once you're in this paradigm, chipping off some workloads out of those VMs and into containers was a much easier task.
Absolutely. That's called the strangle method, and that was developed. That developmental method was developed after OpenShift virtualization really hit and people started migrating. And I'll talk about that when we do the demo. So this is just a little slide on KubeVirt, just to let everybody know where it came from and what its stats are and that kind of stuff. Again, it's not new. It's been around for quite some time. It's only, as I said, it's only new because Broadcom did what they did, and now people are looking for alternatives, and they found one. So that's really just this. If you guys want to look, there's some sources down at the bottom of this slide that will go into a lot more detail about KubeVirt and all its features and functions and all the rest of that kind of stuff. I even think VMware is a contributing, or at least they were, to the KubeVirt source code. If you don't have anything, Ron, you can move to the next slide.
VMware talks a lot about wanting to be that cloud vendor, right? That their whole thing, that's what they called it, Cloud Foundation, is that they want to be cloud. I think that the approach, though, is they're closed, right? And obviously Red Hat is open, and Cube is kind of ultimate open, right? So I think that the links are important. If you guys haven't been to the Cloud Native Computing Foundation to understand what that corner of the world looks like and how the growth of that set of technologies is progressing. Certainly there's some things in there, wet paint, right? They're kind of still a little too new to use in production or heavy duty environments. But this isn't one of them. This one has been around a long time and has a lot of maturity and a lot of support.
Yeah. All right. So one of the things that Ron just mentioned is care and feeding and all that kind of stuff. So this is an approach that Red Hat put together after interviewing lots and lots and lots of customers and on their general workflow on how to deploy a virtual machine. So if any of you guys have ever deployed a virtual machine or had one done, you might see some of these steps that your organization has to follow. And the point of this slide is really just to kind of illustrate the sort of, convoluted process that we've all, that everyone has developed on their own to build virtual machines within your environment, right? I've been in this business since the early 90s, right? And we used to deploy servers, physical servers, and that would take a week or two between the time you get the server and you put it in and all the rest of that kind of stuff. And then when VMware's came out, or when VMware became more mainstream in, let's say, the mid 2000s, so to speak, everyone was like, oh, we can have machines so much faster. And then we laid on all the crap about managing them and putting them in inventory and all the rest of that kind of stuff. And then it became just as slow as deploying a physical machine, right? And I think a lot of people do struggle with this today, that it takes forever to get machines deployed because all these people have to touch them. If you jump to the next slide, I will show you the approach that OpenShift allows. Okay, so OpenShift, this is what you're seeing here is a description of a pipeline. This would be a developmental pipeline, right? And the concept is that once you're in OpenShift, you can run anything through a pipeline. Generally, pipelines are done for constant CI/CD, continuous integration and continuous deployment, which means that your developers are constantly writing code and checking it into Git, and then they're running it through a pipeline. And the pipeline does all its QA and blah, 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 blah. Inside of OpenShift, and I will show you this in the demo, all of your virtual machines are reduced down to a YAML file. They're a text file. Obviously, The data, the ISO is not. The image, the data image is not a text file. That is still a thing that you have to deal with because it's legacy stuff. We have to deal with that. However, everything else about that virtual machine inside of OpenShift is a YAML file, which means you can run your virtual machines through a pipeline. So when whoever is requesting a virtual machine sends the request, in this particular diagram, it runs it in through Ansible. Ansible initiates the pipeline and automation, hands it off to Tecton, which is a pipeline tool kind of like Git, that ushers it through the rest of the environment. And because it's all YAML based, it's text based, you can change whatever you need to change. Cloud init, the image, the template, what network it's on, security, the storage, and it gets deployed. No one has to be involved because you've already defined all of this information. If you wanted to automate deploying your virtual machines based on load in your environment, I have an app, I need to spin up another one, you could absolutely run it through a pipeline. The implications of this are kind of staggering when you sit down and think about what could I use this for. And really what it translates to is flexibility. It gives you options on how to manage your environment and what your needs are. You don't have to do it the way that VMware decided you need to do it, or the way that Hyper-V decided, or whoever other virtualization or infrastructure provider. You can do it however you want to do it. That works best for you. Unless you got anything, hop to the next slide.
Yeah, I just have one thing is that, we realize too, guys, I know a lot of folks look at this slide. I always get people asking me what Tecton is because it's a little dog. So the thing to keep in mind is, a lot of folks don't start here, right? Again, if you've never used OpenShift before, you're going to start on the right-hand side. You might go in there and build your templates and deploy, I don't want to say manually, but you're going to be, in the interface, and you're going to be dealing with the VMs kind of in that way. You're going to eventually kind of come to this idea of automation. And the reason that's important is when you think about containers in general, like not the virtualization necessarily, you're going to be able to run containers anywhere, right? If I'm running OpenShift, that could be running in its own environment. That could be running on top of VMware. I certainly wouldn't run OpenShift on top of VMware and then a VM on top of that. That'd be silly. But, it can run on VMware. It can run in its own environment. It can run in the cloud. And I can move those containers kind of anywhere, right? So when you start thinking about the way that platform works, so I can run my workloads wherever is best, and I can move them from place to place, right, in a fairly seamless manner. That's really the underlying thought process, and that's all a very automated and a very real-time type of environment. VMs tend to be a little more static, right? I build my VM, and there it will sit for the next 3 to 5 years. I'm certainly going to patch it and all that stuff, but I'm not going to really modify the VM necessarily all that much. Whereas containers, it's a very high touch, very constant change where I can make it match my current need kind of any given Sunday. So when you look at this pipeline, don't think that, well, I have to implement everything on the screen here to be successful. You don't. We can move the VMs into the platform and run them as VMs, but just think you're going to kind of be moving to that left side of the screen over time as you start to think about automated deployment, automated caring of the environment, and especially as you go from virtual machines and into containers, this concept becomes much more impactful.
Yeah, this is absolutely an aspirational slide. No one would ever start there. And this is
and I think
leads right into the
pretty well.
This is exactly the point of this, is modernizing at your own pace, right? So if you want to move to OpenShift virtualization, you can absolutely move all your VMs to it and never touch them again. Not make one change in your development process. Don't change any of your applications. It'll work fine. However, if you want to, you can modernize at your own pace. Nothing is going to force you to start rewriting your applications or change how you do anything. You can still deploy virtual machines in that pipeline and all that stuff we showed. You don't have to use any of that stuff at all. You could just deploy them, and we'll show you in a demo. We'll deploy a virtual machine so you can see the process. But you can absolutely do that. No problem at all. What I find most customers, once they move to it, then they start looking at what they can do. And this is when we start trying things. Well, we can do this. We can do that. Yeah, you can. And as Ron mentioned, you can move containers around. You can move virtual machines around too, because they're containers to OpenShift. Do you want to do that? Probably not, but you could, right? Just because you can do something doesn't mean you should do it, right? We all know that, right? But that's the thing. OpenShift is extremely flexible and very malleable as far as how you want it to behave. And that is only a benefit over pretty much everything else, right? That flexibility is key to being able to meet whatever demands the business unit comes down and says, we need to do this thing by tomorrow. And now everybody has to scramble to figure out how to do that. And that really means flexibility, right? Flexibility is kind of the key to getting that done, to being able to accommodate whatever is coming next. So we can go to the next slide unless you got anything, Ron.
Yeah, one thing on that, I would just say that the thing we really see that unlocks that innovation is, the heavy lift in any IT organization is bringing new technologies in. You already have enough technologies to deal with every single day, right? So the idea of bringing new technologies in like OpenShift, once you're in the platform though, right? You've licensed the platform, it's licensed based upon the underlying hosts, right? So now I'm running VMs in this platform. You've already made that investment. You're already in a place where you can innovate. So there's a very low barrier to innovation. I don't need to bring in, different software or different hardware or different whatever. I have a place where I can do those innovations. And so once that platform's there, you're going to find that ability to start moving. And the nice thing is VMs are heavier than containers. So as you move to containers, you're actually making more headroom. So you're going to find it's one of these things where it really does lend you to go towards a modern approach and lend you to innovate in your environment. And I think this is a differentiator amongst other offerings that are out there, because a lot of things that we talk to our customers about when we got to get off of VMware, where do I go? A lot of times wherever I go, I'm going to be left with running VMs at the end of the rainbow. So I spent all this time and coin of the realm and effort, and I've moved off of VMware, hooray, and I'm not paying Broadcom anymore, which is what the top of the house wants, which is great. But I'm left with VMs, and I'm left in a place that it doesn't really allow me to really take that next logical step and really start to modernize my workloads in a different way. And so I think this unlocks that in a way that other offerings don't necessarily do. But it is, again, an option. So you can move and stay for a little while, right? So there's no impetus that says, well, you must get off of VMs in 6 months, right? You don't have to get off of VMs ever, right? But you have a place now where doing that's going to be way easier. And as you will look at new workloads that come in, a lot of vendors, IBM is famous for this. All of their offerings are now offered, as cloud, they call them cloud packs, but offered as OpenShift offerings. As you bring new workloads in, there'll be a place to run those new workloads in that modern way, not as a VM. And so, having the platform in your environment is going to unlock a lot of innovation for you over time.
Absolutely. All right. Okay, and now you're all thinking, how do I get my VMs moved? Okay, so Red Hat has a tool, part of OpenShift. It's called the MTV, the Migration Toolkit for Virtualization. And we'll do a demo of this as well, so you can see it in the demo and as soon as we're done with the presentation. But basically, it's a GUI. You connect it to VMware. You connect it to your OpenShift. I mean, it lives on OpenShift, but you still have to do some configs nonetheless. You go in, you get a list of all your VMs, you select the ones you want to VM, you want to move, you map out the network and the storage, and then you hit go. And what it does is if you have change block tracking turned on, it's a warm migration, right? If you do not have change blocking turned on, it is a cold migration. And then of course you're going to have to do the cutover, right? It will not do the cutover for you. So it will copy everything and it'll just sit there until you're ready to do the cutover. So there's still some organization and coordination that needs to happen. But, there's a tool. It works really well. I've done it a billion times. It works good. There's not much else to say about it other than there's a tool. It's free. You're good to go.
And this is one of the things, guys, running in the lab. So again, it wouldn't be like, hey, try this for the first time in your environment. You can come and get very comfortable with how this works. And I would say that most folks we're working with, do tend to start in that maintenance window, right? They don't necessarily want to try it live with live stuff. Non-disruptively, they'll usually say, okay, well, I've got a maintenance weekend coming up. We're going to move some dev or move some environments and kind of make sure that we have a place to fall back if it doesn't work. Not that it's not going to work, but there's just that kind of just IT feel of if it's new, we want to be very cautious in doing it. So, but once you're comfortable with it, then the migration becomes a little more automated with the tooling. But again, something you get your hands on before you start to use it. So.
All right, you want to jump over to the next slide?
Yep.
I think we're coming to the end.
The terminology comparison.
So I threw this in here as a longtime VMware guy. I did VMware consulting for many, many years. And this is really the thing, right? When you get into OpenShift, none of the existing words that you're familiar with are there, right? So this is just a simple slide based on my interactions with customers over the last year of the things that they mostly run into problems with, right? So just a little, we'll talk about these just briefly. Inside of VMware, you have data stores for storage. OpenShift, they're called persistent volume claims, PVC, because it's a persistent storage that you need for that particular thing. In VMware, data stores are one big data store, and you put many, many virtual machines on it. That data store has to be shared between all of your ESX hosts in the cluster. OpenShift doesn't do that. It takes a single data store, a persistent volume claim, and attaches it to that virtual machine. Wherever that virtual machine goes, it attaches that persistent volume claim to that virtual machine. So the storage kind of follows the virtual machine around the Kubernetes environment. And that is mostly conceptually the differences between the way that VMware does it, or most traditional hypervisors, and the way that OpenShift does it. In OpenShift, because you have Kubernetes there, Kubernetes follows around your pods in the environment and attaches the things that they need. It attaches the storage, it attaches the network, it attaches the services. So that's not something that you need to worry about as the administrator. Kubernetes handles it. There are some pluses and minuses, as always, with anything else, right? So as we go down this list, as far as non-disruptive VM migration, they call it live migration and OpenShift. They call it vMotion and vSphere. They don't have storage vMotion because storage doesn't move inside of OpenShift. Obviously, the physical network configuration, we'll talk about this a little bit with the NM state operator and the Multis. In vSphere, they use vSwitches and DV switches, right? There's no switches inside of OpenShift. Then, of course, there's the networking. They have NSXT. If you're using NSXT, that is something unique and special that we need to concern ourselves with in OpenShift, only because we have to use different tools, depending on what you're trying to accomplish. And then, of course, you have your metrics and stuff like that. It's not very different. It's just different terms. And as you get into this, you'll see it's pretty straightforward. I think that's the last slide. Is that the last slide, Ron?
We'll come back to a couple more slides after the demo, but yeah, I think the two quick points on this slide. One is, and Grant will show you in the demo. Like again, storage is different. You look at storage vMotion. What do you mean you can't do it? It's not that you can't. It's that you don't need to. The storage just works differently under containers. And I think the thing to think down the road a little bit is, the reason for that is in containers, persistent storage does not have to be a thing, right? Oftentimes a container will stand up, attach to some storage, run what it's running, and then when you blow the container away, when you turn the container off, which happens all the time in a container world, the storage goes away too. It goes back into the pool, right? So clearly with VMs that doesn't work. I need persistent storage. I need that storage to persist after I turn the VM off or after I turn the container off. I can't delete the storage. I need that storage to be there and be persistent. So it's a little different, right? But the storage attachment's a little different. But be thinking like 2 steps ahead of, okay, well, why is the storage acting differently? Well, it's acting differently because when I get to non-persistent environments, which is a lot of containers, not all, right? We talk about database and other things that may be parallelized. I need persistent storage for them. But when I get to non-persistent containers, then the storage doesn't need to last past the container's lifecycle. So that's why the storage is built that way, and we're going to see that live here in a second. But just that's one of the reasons to think about storage differently. The other piece is when you think about, again, what you're using in vSphere, not everyone's using NSX, not everyone's using vSAN, not everyone's using ARIA automation. If you happen to be using ARIA automation, that really is an Ansible conversation. That's not really part of the OpenShift family. It's Red Hat Ansible. It's a different offering, but certainly exists. And so when you try to do these matchings, it's more what parts of the VMware stack are you leveraging, and then what are we utilizing in OpenShift instead? I know a lot of customers I've dealt with are, again, they're running VMs, but they're not running VMware's networking stack in a heavy way. They're not running VMware's storage stack in a heavy way. And the operational and automation stack, again, your mileage may vary. So we always do that mapping before embarking upon an OpenShift virtualization deployment. We want to make sure we're covering all the things you used to cover, and then obviously offering whatever new enhancements we can offer with the platform that are baked into it.
Yeah.
But I
I
think
mean,
that point,
NSX is, yeah. I'm
okay.
sorry, go ahead.
I said I was
Well, I was
stop
just
sharing
saying,
so you can share for your demo.
gotcha. I was just saying NSX is something that over the years I have run into very few times, right? Lots of people play with it, but it's not anything that anybody needs necessarily. So, all right, so we're going to jump into the demo here. Any questions you guys have, post them in the chat. This is the part where I usually expect a lot of questions, particularly from VMware guys. So this is an OpenShift cluster. This cluster is running in my lab. It's just a regular old cluster. It's running on 3 Dell machines. I don't even know what they are. We can go ahead and take a look at them real quick. These are them. Does it tell me what kind of machine it is? There it is, PowerEdge 630. They're not all the same. They're a little bit different as far as resources and all the rest of that kind of stuff. Just like VMware, you can get into the nuts and bolts and make everything exactly the same, or maybe you don't have to. Kubernetes will figure it out based on what it has. So this is the traditional OpenShift interface. This is what you see over here on this side, on the left-hand side. You got your home, your operators, workloads, virtualization, migration. This migration is the MTV tool. All your networking is here. All your storage is here. Builds, observe. This is all your metrics and so on and so forth. Your dashboards for everything, performance, resource, cluster, blah, 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 blah. This is where your actual nodes are, that kind of stuff, user management, administration. This is, you want to update a version of OpenShift, whatever, whatnot. This is failing because I won't update it, and it doesn't like it. All right.
A quick note there before Greg gets into this is that understand too, this is not OpenShift virtualization is not a different OpenShift, right? It's not like, well, no. I'm going to install OpenShift and now I'm going to install OpenShift virtualization and they're not the same. You install OpenShift and then you add the virtualization operators to it, right? So when you look at this environment, don't think of, well, it's a different product. It's not. It's all OpenShift. And so it's going to allow you to run lots of different things, including VMs, but based upon how you deploy it. But it is not a separate entity. It is something that you put onto OpenShift itself to support the virtualization bits.
Right. So this is why I start off. Yes.
Sorry to interrupt. We had a question come in. It says, I need to use SAN snapshots for ePIC DB backups, and we accomplish that using VMware RDMs. Does this product have something similar?
Yes, it fully supports snapshotting, and you can, depending on what storage solution you use, you can spin off those RDMs by themselves, or you can deal with them as the same as normal snapshots. The question of what storage solutions you use is a big one. There is a vSAN alternative in OpenShift that's called ODF, OpenShift Data Foundations, and it's a software-defined storage solution which does a lot of stuff. Of course, IBM has solutions. You can use your traditional storage arrays. We're going to have a whole discussion about storage, so I'm going to get down, not get into the weeds right now about that. But yes, it does support snapshots, and you can download those snapshots and use them for backups or whatever. OpenShift also has a backup utility. It's called OADP, which does backups and all the rest of that kind of stuff for you. I don't know if this would be a solution. This is kind of an alternative to Veeam. That's my understanding. I've never used Veeam in a production environment, but so that's what it is. I'm showing you the operator page just to go back to what Ron was saying. If you see, this is OpenShift virtualization. It's an operator that I installed on this OpenShift cluster. The migration toolkit, an operator I installed on top of here. ODF, operator installed on top. Operators are how you install packages and different things like that. And of course, the operator hub, which is this, is ridiculous. Everything is in here that is an add-on to OpenShift. Most of the ISVs, the independent software vendors, as you see, we have Amazon controller for Kubernetes inside of OpenShift. There's your NetApp. These are operators that the community has written. Some of them are certified, some of them are not. The certified ones come from Red Hat, and that they say that they are actually going to work and not break your stuff. See, we have this VMware, Quest, Anchor. These are all ISV operators, right? So it's very extensible
and
platform.
A quick point on that too. It's not just that VMware will support them. Certified are actually supported by the vendor themselves. So you see when VMware AKA operator provided by VMware, if you call VMware, they don't go, well, that's not our problem, right? Both sides, when it comes to certified packages, this is also true on the Ansible side. Both the vendor and Red Hat means they've come together and said, yep, this is a blessed thing. And again, the other operators that are more community or more open, they're very functional. It just becomes, if it's heavy and it's load bearing, I think, there's a question about, epic environments. You want to make sure that the vendor's totally on board. So you don't do something and say, well, you download something off the internet and use that instead. Even to the backup environment, again, depending on how you're using your backups, oftentimes we'll just back up the VMs as VMs and we won't think about them in a different way. We have to solve for backing up the container platform. So you have to think about that problem. But again, when we think about ops disruption, right, when bringing in new technologies, oftentimes we'll try and do the least disruptive thing when it goes in and then improve over time versus, break a bunch of stuff and then run it differently, in the container platform.
Correct.
So we have one more question on this. Is it fair to say that OS is really only optimal for workloads that you're intending to modernize at some point? If workloads will remain traditional VMs forever, then things like not having storage vMotion are a real concern. Yes, traditional VMs will run under OS, but at the cost of not having functions like SVM.
No, that's not true. You don't need storage vMotion with the way that OpenShift manages storage. There's no reason to move it around. If you wanted to evacuate your data stores, right? In the event that you needed to remove one or add something, you can do that. It's just not storage vMotion, right? Because we're not actually using one giant data store to store an ISO file on or a data store file on, right? A VMDK file, and then move it around. That's not how that works inside of OpenShift. There is no reason you could not move any virtual machine, whether you intended to migrate it or modernize it or not. You can absolutely do that. In my environment, none of these virtualized machines, if we look at these, none of these will be modernized. They're jump boxes. There's a RHEL jump box. That's a Windows jump box. These will stay here forever because it's a lab environment, right? So no, it's not a problem. I realize you're thinking it is, but it's really not as much of a problem as you may think.
Yeah, I think, Grant, as you get into the storage, that's going to make more sense. I don't think of it so much that the function's not there. It's that the function's not needed in the way that storage is deployed.
Correct.
The storage is
it is not necessary.
It's attached differently. I think it's the easiest way to say it. I'm not saying it's better or worse. It's just different than the traditional. I have a LUN and I attach it over my SAN, and that thing is linked together, and then I'm not going to touch that configuration forever because it just persists and it just is. Containerization by its very nature treats storage as something that can come and go and move and do different things. And so, but when Grant gets into the storage side of things, I think that'll make a little more sense.
Yeah, which we'll cover that, but I want to start off with the virtualization part of it first. So if we jump into the virtualization tab, this is our general overview, and you're going to get some brief information about what's happening in the environment. Obviously, this environment is not heavily utilized. You got your typical things over here, top settings and all the rest of that stuff. OpenShift by default comes with the concept of a catalog. If anyone has ever used Amazon or Azure, You're going to be familiar with this. You pick the kind of machine you want and you deploy it. I have not set up and configured any of these because we're not using them this way. We're using templates, right? Just like everybody uses for VMware right now. So we're going to go ahead and deploy a virtual machine so y'all can see that. We're going to deploy it from template. So this is default. This is what it comes with by default. Any of these where it says source is available was provided, and there's an ISO for these particular versions of the operating system. Windows does come by default with these templates, but no ISOs are provided because that's a purchase thing and you have to buy those. So Red Hat does not give them to you. So we're going to deploy a rel box just because it's convenient. So we click on the template and then we get this little screen here. If we want to customize, we can customize the virtual machine here, and this will bring up your standard customization stuff. We do have a little bit of customization right in here. We can specify how big we want the disk to be, any kind of optional parameters if we want to change the default password, the data source name, not that we would change this, where the data source is located, that kind of stuff. We'll go into the customize your virtual machines just so we can see what options we have, and we have everything that you would normally have, right? So network interfaces. In this particular environment, I need to specify a different network bridge, and I'll talk about that in just a moment. We have our disk thing here. We can modify the disk. We want to make it bigger, smaller. We're not picking a disk to put it on, right? So this also lends towards, remote desktop. We aren't picking a disk. Kubernetes picks where I put this. Now you can specify storage classes, right? So if we have faster disk, slower disk, cheap disk, expensive disk, however you want to put those guardrails around Kubernetes to say only put this kind of workload here. Kubernetes decides where to put it based on utilization, free space, requirements, long laundry list of things that it does. In the script section, this is where you're going to have your cloud init for Linux boxes or sysprep for your Windows machines, right? In this environment for my Linux machines, this grant rel, this is our primary jump box. So every virtual machine that gets deployed in this environment has an SSH key from this machine, right? So that I can always guarantee that this machine can connect to any Linux box that's out there, regardless of usernames, passwords, all the rest of that kind of stuff. That's just how I do it. Obviously, y'all can do things however you're going to do them. This, as I was talking about before with your text file, this is your YAML file that specifies everything about this virtual machine. And of course, this is a text file and can be edited with any text editor or through any pipeline sources, right? Ansible can modify this, whatever you need, right? So
Yeah,
it
I
gives you
think
lots of opportunities.
that's a super important point because what we tend to find is if you are primarily a Windows shop with keyboard and mouse guys, you'll come to this interface and kind of deploy virtual machines. We find that if you have heavier Linux users or if you have more a propensity for automation, right? I'm going to have my developer go to ServiceNow and open a ticket and request some machines. This will all kind of happen, right? Nobody's there with a keyboard and mouse, like clicking around the way Grant is showing. This interface is great, especially if you're doing to get familiarity and to do some one-offs, right? But what we find is in faster moving environments, a lot of this is done at that command line. So the fact that you can see all of this source, you can see exactly what's going on, and that's very modifiable. This is what's happening under the covers, right? This wrapper, this GUI wrapper, when you say go, it's running this basically.
Correct. Yeah. So one of the things I was talking to a customer just the other day about using this, and I thought this was a really good example. So just as you said, ServiceNow. So to get ServiceNow to deploy a virtual machine, you need something in between, right? So if we used Ansible, and we would take ServiceNow and we'd say, developer says, I need a machine with 1 CPU and 4 gigs of memory and 100 gigs of hard drive space, and we click the button. Now we can accomplish that by using a template, using the catalog item. We have a lot of ways of building that. One of the ways of building that would be to take this YAML file, customize it either in ServiceNow or Ansible, and then squirt it over to OpenShift and say, build me this YAML file. You don't need templates, right? All you need to do is specify the data source name, and here it is right here. It lives in this virtualization OS images. It lives in this namespace. This is the name of the data source, rel 9. And if you wanted it to be rel 8, rel 6, rel 5, Fedora, Debian, whatever, it doesn't matter. Your naming schema would be what you'd put in here, Windows 2000, whatever, and bang, there you go. There's your size. So really, you're just modifying text files. The text files become your templates. You still have to have the data source, right? You got to have that, but it's not connected to that template, right? There are some very distinct advantages to that if you all think about managing your VMware templates. Every so often, someone has to turn it on, do updates, blah, blah, blah. You don't have to do that at all. This is basically the ISO, right, to deploy an operating system. So there are some very interesting options doing things this way. But without going too far off the rails, back to the virtual machine. So we've done all modifications, whatever it is we need. I've changed my network because I needed to be on a different network for it to get the right kind of IP address. And then we hit create. So here we go. We're deploying a virtual machine. We have our little web console over here. If we click on this and we can view diagnostics, it's going to tell me what's happening, right? All the VMs are bound. Here's the cloud init. I don't think we've gotten to this point yet. The data volume status, what's happening, clone's completed, and it's running. Look at that, there you go. Now we go to the web console, just like anyone else web console. There is kind of one thing that's nice. We have the VNC console, but we also have a serial console. So if you need to be plugged into the serial port of a server, which sometimes you do, this is nice that we have that ability to switch back and forth between the two. Another thing I just find this to be a nice little plus is the guest credentials. So these are the ones that come default. And because you can't copy and paste into a terminal window, you can copy and paste through this interface, right? So which is super convenient in my opinion of being able to get in here and be able to copy and paste those credentials in and out. All right, so now we'll do a migration just to show you migration. So you see we're on node 3, worker 3. And because Kubernetes is in the middle, we don't say where we're moving it to. We just say we're going to migrate it. And eventually Kubernetes will look at the environment and just move it to another worker, just like that. It takes a look at the environment and makes a decision based on the criteria that it has, which machine it's going to move it to. So it just moved it to worker 2. So just before anybody asks, in the event that you need to take a host out, you come in here into your nodes, and instead of putting it in maintenance mode, you mark it as unschedulable. And when you mark it as unschedulable, all of these 108 pods go somewhere else. Doesn't matter where, just somewhere else between these two machines, right? These are our control plane, our master nodes, and these are our worker nodes. So you have 3 of these almost always, and you have as many of these as you need. If you need 100, you have 100, right? It doesn't matter, whatever you need. So that's how we deal with that kind of stuff, all right? So this is our rel box here, our rel 9 Coffee Scorpion, and obviously you can change those names to whatever you need. As you can see here, these are my IP addresses with all the things. So first, let's talk about OpenShift networking, right? So by default, when you try to deploy a virtual machine, it's going to want to connect it to the pod network, right? What the pod network is it is the network inside of OpenShift. So the pod network is anything inside of OpenShift can talk to OpenShift, right? Can talk inside. So if you have 2 virtual machines on the pod network, they can talk to each other. They can also talk outside of OpenShift, right? So if they need to get at a gateway or whatever, whatnot, they want to talk into the world, they can do that no problem. Nothing can talk in to the network. This is a built-in standard security feature, right? Whatever's inside the network, inside OpenShift, is isolated from outside of OpenShift. And that is managed by several procedures, several methods, whatever, whatnot. However, For containers, you probably want that. For virtual machines, you probably don't want that, which is why I had to come in here and change it to a different network so that it would be on the outside world. So by doing this, changing it to this network in my environment, it has created the same kind of networking as I would expect inside of VMware. I deploy a machine, it's plugged into a switch, it has access to the world. There you go. That's what we've done. In OpenShift, you have to explicitly configure that. So I'll just jump into networking real quick right now. So the first step in your environment is to take a look at what you got. So these are my worker nodes. As you can see, they have, this one has 3 NICs, because like I said, they're not all exactly the same hardware, and this has 5. So these are Dell boxes, and they have those multi-function NICs in them. So our primary NIC on all of these machines is ENO1 NP0 that's plugged into one switch. ENO2 NP1 is plugged into another switch. So we have multi-switch configurations on these racks with all of these servers. What I had to do was create what they call a network node configuration policy and a network attachment definition for creating these networks. So as you can see here, I have a bridge 1 for ENO1 and then a bridge for ENO2 that allows me to create this bridge network to get all of my worker nodes on the outside. Now, I realize that this is totally different than what you're used to looking at and what you're normally used to seeing. There it is. No, that's not what I wanted to show you. Hold on a second. No, that's not what I want to show you. Do you guys see a terminal window? Anybody?
We do.
You do? Okay, good. All right. Let me minimize this window here. What I wanted to show you was how I created this file. So these 2 bridges, that is what they consist of, right? So I understand that it looks complicated and all that stuff. This is what they actually consist of. And this particular file, I copied off of Red Hat's documentation. I copied it just straight out of the docs. And I changed the things that I needed to change, the NIC, the name. That's it, right? Nothing else needs to be done. The other thing that's kind of cool about it is you see this node selector, IO workers. That is a big thing inside of OpenShift. You do labels, and then you give Kubernetes information to pick things. So you say node selector, it's a standard Kubernetes function, and we're only going to apply this to workers. If I had, particularly for, let's say, AI workloads, you probably have some worker nodes that have GPUs in them. So we would call them GPU worker or something like that. So we would say that this node selector for this network only goes on like VM workers, right? Don't bother putting it on GPUs. And then when you're deploying virtual machines, you say they can go on VM workers, right? Not on GPU workers. You're not going to waste your GPUs by putting virtual machines on there, right? This is a big thing inside of Kubernetes, is these different selector roles. This is a common thing. You'll see it in the YAML all over the place in Kube, and it's something that you can leverage, again, for your flexibility. Let Kubernetes do what it does. You just give it the guidelines, the guardrails of how it makes decisions in your environment. And that's how you do that kind of stuff.
Yeah, I would say, Grant, the thing that I've seen, this is a very hard thing for folks to let go of, right? I mean, a lot of us have been in technology a long time. We're all IT guys, we're all geeks, we kind of know how this stuff works. And that loss of control it freaks a lot of people out, right? This idea of, what do you mean the machine's going to decide where it best goes? Now, I'm like, I'll decide where it kind of best goes. And so you start to see some unnatural things, right? I'll put these constraints around, well, this application is going to run in this place that I tell it. But if you think again, if you just take a step back about where this is all going, of it can run anywhere. It can run in the cloud, it can run on-prem, it can run over there on the side. Like the idea of, no, go wherever is best. And the application doesn't know or care. Now, again, you have some environments that I know are very, they've got a lot of constraints around them, and that's fine, and you can build that way, right? And oftentimes what we'll find in that environment is you'll build your own OpenShift cluster for whatever that particular use case is, and it kind of lives over there on the side. But you can move these things between clusters and between environments, and let it be whatever is best. And what does best mean? Best can mean cheapest. Best can mean best performing. Best can mean whatever the minimum performance requirements are. So don't go to the top of the chain, but just here are the things I need from a IOPS or network, whatever it is perspective, and that's the way you're going to put me. And so that loss of control, I think, has been the biggest jolt to people making this journey. Of I used to really have firm control over, I'm going to put the stuff where I want it. I'm going to have all those hands on it. If you think about this world, it's like, no, as you add resources moving forward, that's just going to add to the pool. And now that's going to give you more flexibility for your workloads to run wherever they're going to run. This becomes insanely powerful on the container side of things, right? For the VM, it gives a lot of benefit, but you're still kind of living in one place. Once I go to pure containers, and I can run lots of things anywhere or multiple places, and this idea becomes very, very powerful. So just don't consider wow, I have to let it do its own thing. You can put guardrails around it, but don't put too many. Right? You put too many guardrails around it, and now you're losing that flexibility as you move forward.
Yeah. Well, one thing to keep in mind is I understand that it feels like a loss of control. The problem is that with Kubernetes, you have an unlimited amount of granular control. You didn't have this before, right? So with VMware, you can say what data center goes on, and kind of that's it, right? What data store and maybe what host you're going to put it on. In Kubernetes, you have control over everything that Kubernetes does. It's too much. It's too much control. You can't make all of those decisions because you don't know, right, exactly what the right thing to do is. So this is why I call them guardrails. We're going to set up guardrails for Kubernetes so that it behaves more of the way I expect it to than how I want it to, right? I expect it's going to do this. I expect it's going to do that. When there's a failure, this is what's going to happen. And this is what makes systems robust, is that they behave the way you expect them to behave. So that when you're writing your applications, you know what's going to happen when it fails. So you have an expectation. You can get into absolutely manual, granular control with Kubernetes if you are so inclined. Most people don't do that. Now, this would be if you build your own Kubernetes cluster and you want to, what I call naked Kubernetes, because OpenShift and like Rancher and EKS and AKS, these are all wrappers around Kubernetes, right? When you build your own Kubernetes cluster, you don't have that wrapper. And so therefore you're dealing with Kubernetes directly. And then you have to do all the things. You have to tell it to do everything. And most people don't like that. So you don't want that level of control that Kubernetes gives you. It's just too much. You'd have to have one person dedicated to doing nothing but managing Kubernetes. And it's supposed to be the other way around. Kubernetes is supposed to manage stuff for you, not you manage Kubernetes. Philosophical differences, but I think if you move into this platform, you will start to appreciate the flexibility without the micromanagement. That's what I appreciate about it. So. All right, so networking services. One thing I wanted to talk about, services and routes. They used to have nothing to do with virtual machines and everything to do with microservices. But as I mentioned with the pod network, how you get data into OpenShift generally is through routes, right? You can do this bridge thing that I did with the network, but for containers, you wouldn't do that because you don't attach containers to networks, right? You attach containers to services, and then services have routes that go out to the world. And again, I don't want to get into it, but I just want to show that there is this functionality exists. And the key to a service is, let's say, take this one for agent registration. While you're writing your application, you wouldn't say talk to this machine on port 9091. You would say talk to the agent registration service. And Kubernetes manages what this is on the background, right? You define with labels and all the rest of the things in Kubernetes what this service is, and then it just manages it, right? Same thing with routes. You define what you want it to be. This is the location of the particular application for this agent registration, and there you go, right? Ingresses is data coming in. This is like a custom route coming in that has nothing to do with the service. We're going to ignore that. All right, do we have any questions before we move on to the migration tool? I don't know, I can't see that interface real quick.
Yeah, I don't see any new ones coming in yet.
Okay. All right, so we're gonna just fire up a migration, right? So we have these providers. This is the host cluster, my OpenShift cluster. This is my VMware cluster. If you have multiple virtual centers, then you will have multiple of these. This is just me playing around for one of the guys at work. And then we're going to make a migration plan. You can see there's several of them in here. I do a lot of demos in this environment. So we're going to make a new one, and we want to come into that one there. We're going to grab one of these jump boxes. Let's do this one. Oh, hold on. Let me see which one is turned off. And none of them are turned off. Nice. All right, well, this one's getting turned off. Hopefully no one's using that. All right, where?
That's like hitting the power button. You usually gracefully turn it off. I know.
It's a Windows box. It's a Windows box. I don't care. Okay, so we picked the box. Now, again, you can do the migration with it turned on, but I don't have change block tracking turned on in my cluster. So it's a problem because, you know, OpenShift and Red Hat know that if you don't have change block tracking, you're not going to get an actual, you know, good copy of the environment. So, yeah, see, it's complaining. Hey, this is not okay, guys, right? So we're going to hit next. We're going to give it a name. Doesn't matter what it is. Well, this is our namespace and all the rest of that. We're not going to get into all that kind of fun stuff. And then we got to do a network map. Now, I can put all these into pod network, but it's not what I want. I want them to go into the bridge network because I want them to have access to DHCP. Same thing with the storage maps, right? So in this particular situation, all of my storage goes in this storage class. This is a storage class. And the reason for that is because this is a pool of storage that I want to be able to grow in the future if I need to. So I just add it to here and let all the software defined storage solutions manage it, right? This is ODF. ODF is Ceph under the covers. If any of you guys know what Ceph is, if you don't, we can certainly talk about that at some other time. But that's it. So we create the migration plan. It's going to go through and try to figure it out. And if it says it's ready, then we start the migration. Now, how big is this box? This is 100 gigs. Wow. Okay, that's going to take a while. So this is the process, right? We migrate the machine, then we can click on here and see what's happening with it, the status, whatever, whatnot. Now, there's nothing magical in here. It's going to take a while to move 100 gigabytes. It's going to take a while. There's nothing I can do about that, right? It's going to take as long as it takes. It's certainly not going to finish before the end of this demo. And that's just how it goes. But once it's done, this is what you will get. And if we go back to this one, the VM is not okay. I've mostly deleted these virtual machines. Let's see if any of these are still here. They are not. And that one's not even still there. But, you know, basically you get dropped off into this pile here. This one is a migration, and this one also is a migration. And there's nothing different about them other than they're in a different namespace. Just by real quick, namespaces, if you think about namespace has a whole thing in OpenShift. We can ignore that in the case of virtualization. Namespaces are folders. If you think about folders in Virtual Center, right, that's what namespaces are. When you give, so I'm logged in as administrator. When you log in as a developer, you only have access to the projects, the namespaces that we gave you, right? That whoever decides who gets access to what, that's how you control it. So your developers, or really any other users for that matter, they'll log in here and they'll only have access to the namespaces that you have defined for them. So therefore, they can only see the virtual machines that are in their namespace. So right now I'm in all projects because I'm super user. I can see everything in the environment. But if I just go to, let's say, MTV, our migration. What is it called? OpenShift MTV. Why can I not find this? There it is. So if all I have access to is OpenShift MTV, these are all the virtual machines I'll see. I won't even see any other ones, right? So that is something to keep in mind, that you do have that level of, granular kind of control on who can do what in the environments. Yeah, that's pretty much it for my little demo here today. Any questions? Anything anybody would like to see while I'm here? Ron, you got anything?
I think you're good to keep going, Grant.
Okay. Well, that's all I got
done?
for the demo.
Okay, I'll jump back into the. Oh, I can't until you stop sharing.
Let me. All right. So just as the demo is still there, guys, if anyone has any questions, throw them in there, and we can certainly show you.
All right, so real quick, guys, just wanted to talk for a second. As you guys know, IBM bought Red Hat for a lot of money. And one of the things that IBM talks about is in their storage portfolio, kind of making the OpenShift story better. And they have this concept called Fusion. Now, is this required? It's not. If you guys have compute, storage, networking, if you have a space to run OpenShift in your environment, great. You can run OpenShift in your environment on whatever you currently have, and that works great. There are two kind of use cases here. One is Fusion HCI, which I'll talk about, which is the kind of an easy button to get into this environment. It comes with compute, storage, networking, OpenShift implementation, right? You basically roll it in and you'll have the screens that Grant just showed you. You'll have a place to run your OpenShift virtualization environment, right? So it's a hardware offering that comes in fully baked, fully supported by IBM and Red Hat to run OpenShift. The other one is software only, which is Fusion. Now, Fusion is storage software that you layer on top of whatever you're currently running for storage. Because one of the things, depending on what you're running today, is your storage container aware, container friendly? I'm not really sure how to use it, but does it have all the things you want in this new kind of environment, right? Does it have the ability to do the proper provisioning for a container platform? Does it have the proper security links? Because again, you're treating storage very differently than before. So if you have an existing environment and you're looking to put OpenShift on top of it, we talk a little bit about Fusion. Does it make sense, or does what you currently have handle the 5 things we see here on the page, right? That'll handle the storage in that way. But if you say, and a lot of customers have said this to us, I want to run this environment. I have an application or a series of applications. Sometimes those are IBM and they're already entitled to the OpenShift bits. Or I have a set of VMs I'm looking to move, but I don't have a place to run this thing. I don't have a certified blessed environment to run OpenShift on. That's where Fusion HCI comes into place. Again, it comes in, you size it appropriately, how much space you need, how much compute you need. It comes in as a fully supported stack. And already running OpenShift and already built and get ready to go. And then the ability to then kind of move into this environment. Now, the only question I sometimes get is, well, once I do this, once I use any HCI, we're talking Nutanix, right? Which you can run OpenShift on too if you wanted to. Well, now I have all this other stuff. How do I interact with the rest of my environment? Am I stuck in this kind of appliance-based paradigm? And the answer to that is no. When you think about Fusion HCI, you can use that as a control plane. You can use that to manage your virtual machine environments. You can use that to manage your other OpenShift clusters, whether those run on-prem, whether those run in the cloud, right? So this idea of a beachhead or as a building block to start your journey in an easy button kind of way, because it's already thought out and already ready to go. Fusion HCI is a great place to do that, either for OpenShift virtualization or just for OpenShift itself. Right, so something to keep in mind that these offerings do exist. If there's I would love to do this, but I don't know how I would carve out space, or maybe I don't have any space to carve out. How would I start this journey? This is a great way to start the journey. And then, as I said, if on the storage side, well, I have capacity, but I don't have all the features I need. you can use the software only version. You don't get servers and storage and stuff because you already have that in your environment, but you can layer in the Fusion software bits as well. Again, these are totally optional. We have folks who say, you know what, I've got plenty of servers, I've got plenty of storage, that storage is good to go, and I'm just going to run the OpenShift bits on stuff I already have. Fantastic. And that is one of the other good differentiators. Some of the offerings that are out there don't let you run on your existing stuff, right? You have to run on something else. But so Fusion HCI, easy button and a beachhead. Fusion itself, software you can layer into what you already have, or you can roll your own and don't need either one. But just making you guys aware that this offering exists from Red Hat and IBM, and that is something that we see a lot of success with because it takes away a lot of the guesswork and a lot of the building because it's already kind of pre-built and ready for you. And I think that was the end of the presentation itself.